Welcome back. A couple of videos ago, we looked at how we could model ancestry using binary trees. And we saw how we could precisely specify what it means to be a binary tree using an inductive data definition that defined a tree as either an empty tree or as a node containing some data, maybe your name or your mom or dad's name, and two additional trees, each of which can be either a node with subtrees or empty. With those two rules for forming trees, a tree is either empty or it's a node with some contents and two subtrees, we managed to specify the entire possible set of binary trees of, in this case, of people's names. Last video, we saw how terminal windows, shell programs, and file systems work together to allow you to issue commands to manipulate your computer and how all of that works. Now, one of the components of that setup that we didn't spend a lot of time on was the file system. In this video, we're going to look in a little more detail at the file system on your computer. This will be useful both for helping you to get your machine set up for this class and as an example of another application of the concept of trees and inductive definitions. In this case, your file system will be seen to be a tree of files. Not a binary tree, but what we'll call an n-ary tree, a tree with possibly many nodes under any given node in the tree structure. And you'll see also that we can easily model this kind of more general tree structure with an inductive data definition, where an n-ary tree is either a node containing 0 or more other nodes. In other words, we're going to call this kind of node a directory file. It's a file. It's a directory file containing 0 or more other files, or a file is a data file. So let me say that again. I'm not sure that was sufficiently clear. A file is either a directory file containing a list of files, or it's a data file containing some contents. Go ahead, try to repeat that yourself. A file is either a directory node containing a list of other files, or it's a data file containing some contents and no subfiles. Okay? And these directory and data file nodes correspond to, nodes and empty trees in our earlier example. So we'll see all of this in more detail in this video. Okay, so let's hop to it. So we're going to start by reviewing key concepts from the last two talks, and then we'll bring them together to give you a deeper understanding of how a file system is organized on your own computer. Key takeaway message again, a file system is a tree of files, and we can define what we mean by a tree of files by giving a simple inductive data type definition. We won't try to do that formally here in this talk using Lean, but it will be very easy for us to do that in the very near future. Okay? So the lesson from a couple of videos ago was that we can represent our ancestor structure as a binary tree of people. So we have a person, you, at the top, and your parents below you in the tree, and then empty trees below them. And that cuts off the tree and gives you a tree with 1, 2, 3, 4, 5, 6, 7 different elements in it related by these parent-to-child links. As we saw, we can then represent or specify really what it means to be a binary tree of people by saying a binary tree of people is either a node with a name and two smaller binary trees of people, or a binary tree of people is an empty node. Okay? And those two rules, when you repeat their use over and over again, can be used to build up or to construct sort of any binary tree of people that you can imagine. The second lesson from the lesson from the immediately past video was that you can use a terminal window within which a shell program is running to execute commands on your machine that then allow you to control your machine. Through your keyboard, you can send a command line command to a shell process running inside of a terminal window. The shell process will search the file system for a file that has a program that implements that command. The shell will launch that program as a separate process. That process itself can talk to you through your keyboard and talk back to you through the display, and it can also go out to the file system and read and write information in your file system. Last time we mostly talked about the left two-thirds of this diagram. Today we're really going to focus in right down there on the file system component of this picture. Okay, so let's get started with that. A file system is a tree of files. It stores and organizes the files on your computer into a kind of a hierarchy. You typically see this hierarchy using Windows or OS X when you bring up your Finder on OS X or your Windows Explorer window on your File Explorer window on Microsoft Windows. Now, whereas an ancestry tree we represented as a binary tree because you have two biological ancestors, each person has two biological ancestors, the kind of tree that we find in a file system is more general. It can have not only 0, 1, or 2, each node can have not only 0, 1, or 2 children, it can have as many children as it wants. Okay, so think about it. If a file is either a directory or a data file, well, a directory file can contain many other files. Okay, we can think of those other files as children of the directory file. Now, some of those files might themselves be directory files, and other of those files might be data files. With the directory files, the tree can continue downward. Data files, on the other hand, are sort of terminal or end nodes in a tree of files. So here's a picture of a simple kind of file system. At the very top of the tree, we have a directory file. It has a name called /, and on your machine, the name of the top level directory is /. Okay, if you're using either OS X or Git Bash terminal window. It's a little different if you're looking at the Windows file system. Here we're mainly talking about Unix-like file systems, and what Git Bash gives you is kind of like a Unix-like file system embedded within the Windows file system. So here we're talking about what goes on inside the Unix-like file system when you're using Git Bash. Okay, so the top level node in either case is called /. We call that the root directory because we're at the root of the tree. Yeah, in computer science, the root is at the top of the tree and the leaves are down at the bottom. Okay, so trees in computer science, they're upside down. We draw them upside down. So in this file system, we have a top level or root directory / with a list of files inside of it. Home, that's this file here, another directory file. etc, that's this file here, another directory file. And foo, oh, I gave it the wrong name over here. This should say foo. This is a data file, okay? And so directory files here are represented by these rectangular structures, and data files are represented by these circular structures. Okay, sorry for the typo. You can change this to data, or you can change this to foo, just to make them consistent. Okay? So, the pictures look almost like what we saw before, except the top level node in this case actually has 3 files underneath it, so you can see that it's definitely not just a binary or a two-way tree. Okay, so to repeat myself, a file is either a data file or it's a directory file. A data file contains some contents that you can think of as just a string. A directory file contains a list of 0 or more other files. Each of those could be a directory file or a data file. If it's a directory file, it has a name and a list of other files. Those could be either directory files or data files, and so on until you reach all data files at the very bottom frontier of the tree, at which point the tree extends no further down. Okay, this is a simplified but pretty accurate characterization of what file systems actually look like. Okay, the root of the tree is the root directory, and a path, that's the next concept we'll talk about here, is a list of files that are connected in that tree, starting at the root and following some path down to a file. Okay, so let's take a quick look at our directory structure again. Here we are, it's the same picture that we were looking at before. It even has the same typo here. Okay, so here's our directory, and now we can add some labels. So here we have the root directory. These two files are directory files within the top-level directory file, or linked within the top-level directory file. And so we can think of these as subdirectories of the directory above. We could say that home is a subdirectory of the root directory. etc. or etc. is a subdirectory of the top-level directory. Here we have a data file. It's not a subdirectory because it's not a directory at all. On the other hand, below the home directory, below /home, I haven't drawn the rectangular structure here, but we have another directory, Sully, that's my username. This is in fact the directory on my machine that contains all of my files, whereas some other subdirectory of home might contain the files for some other user on my computer. Okay? Within the etc directory, we have a couple of data files here, one called hosts and one called fstab, and those are names of files that generally live inside the /etc subdirectory on a typical Unix-like operating system. And by the way, Unix, what is this? Well, it's an operating system that was invented in the 1970s. OS X essentially is a descendant of the Unix file system via an operating system called Mach that was developed at CMU, Carnegie Mellon University. Windows does not derive from Unix, but the whole terminal, Git Bash, shell infrastructure does derive from Unix. So we'll just call these Unix-like operating systems, or certainly Unix-like file systems. So a path. A path is just a path through the tree that identifies some file. So one example of a path is just slash, and that little orange brownish slash there is the name of the top level directory. You can use that to refer to the top level directory in your file system when you're issuing command line commands. If we change that to /etc, well, the slash says start at the top root level node and then go down to the etc subdirectory. And if we extended that with another /hosts, here the slash is a separator between different file names. Slash on the left starts at the top. etc takes us down to this subdirectory. Slash is a separator, and then hosts takes us down to this file right here. So in your terminal shell program on OS X or in Windows, you can refer to files, and you do refer to files by their path names. In fact, the real name of a file is given by such a path. Okay. So we're going to stop here and just take a very, very quick excursion over into the command line terminal window, and using the ls command to list the files in a directory, we'll just see a little bit about what's going on, and then I'll come back and tell you a little bit more. Okay, so a detail about ls. The ls command generally gives you the list of files in your current directory. That's a concept we'll get to very shortly. The ls command also takes a path as an optional argument. Okay, and so we'll see how that works. Okay, so we'll be right back. Okay, so here we are in our terminal window. In the upper left here, you can see an informational line saying, what my username and what my machine name are. MingGW64, again, that's the name of the shell process. That's actually the technical name of the shell process on this, in this git bash installation of a simulation of a Unix computer running here on my Windows computer. And this last little bit is slash, and that tells me, it reminds me what my current directory is. Okay, so ls all by itself will give me a list of the files in that root directory on my git bash terminal window. Okay, and there you go. And look, right here is etc, and there are some other files here. Oh, look, some of the files have slashes after them, and some of the files don't. There you see the difference between a directory file and a data file. Okay, so the top level directory has a mix of files. 1, 2, 3, 4, 5, 6, 7, 8 of them are directory files, and 1, 2, 3, 4, 5, 6 of them, 7 of them, if I've counted correctly, are data files. Okay, now, a minute ago I said you could provide ls with a path as an argument. Let's try that. ls, how about /etc? I'm asking for a list of the files inside of the etc directory whose parent is the root directory, which is also the current directory. Okay, so now I get a list of different files, a list of the files in the etc subdirectory of the top level directory. And look, there's fs tab, there's hosts, and there's a bunch of other files in here. The files in this directory are generally used to configure things like networking on your machine, and you'll probably never, at least for a while, you won't be touching these files unless you're kind of a programming system-y person. Usually there's not much cause to touch these files until you get further along. Okay, so good. Now let's head back over to the slide set, and we'll talk a little bit more about command line commands, and we'll learn some command line commands other than the ls command. Okay? So on to the next slide then. Next key concept. Your shell keeps some information for you. In particular, one of the things that it keeps is it remembers what your current working directory is. So we'll call that the CWD, the current working directory, and that's a path to some directory somewhere on your machine. When you log in on an OS X machine to a new terminal window, the current working directory is typically set to your home directory. Using git bash, it can be a little bit more complicated, but we'll get to that. We'll get to that in a couple of minutes. Okay, so just remember that your shell remembers something called your current working directory. Now, shell commands, as I said, usually take a path as an argument. But if you don't provide a path as an argument, they will typically use your current working directory. Now let's talk about paths. If a path starts with a slash, that means you're starting way at the top of the file system tree, okay, and working your way all the way down. We call this an absolute path. If a path does not start with a slash, then your shell will fill in the entire path from the root directory to your current working directory, and then any file names you give after explicitly as an argument to your command will be appended to that path. So we call this a relative path, okay? It's a path relative to your working directory. So if you're in your home directory and you say ls space foo, then what your shell will do is change that into ls slash home slash sully slash foo. Okay? it allows you not to have to give explicitly the entire path from the top of the tree to your current working directory. You just give everything after that, okay? Now, a couple of Unix commands to be aware of. Very, very useful and important to understand these in order to be able to work with your system. pwd is the print working directory command. If you enter the command pwd in a terminal window, it'll just print out what your current working directory is. ls, as we've seen, will print out a list of the files in a given directory. If you don't give any argument, it will use your current directory. If you give an absolute path, it will use that absolute path as its argument. If you give it a relative path, it'll use that relative path as its argument. Now, sometimes you want to change your working directory. So, for example, if your current working directory is your home directory, but you're working on homework 2 and you want to be in the CS2102/homework2 directory within your home directory, you could say cd space homework2/2102, CS2102/homework2. Okay? Again, if you want to be in the CS2102/homework2 subdirectory of your current directory, you could just say cd space CS2102/homework2. That will change your current working directory in the shell's memory to be that new directory, and now it's as if you're kind of working in that subdirectory, and any commands you issue like ls will now take that directory as the place to start. Okay? A couple of shorthands. Your shell gives you a way of referring to the current directory. That's dot or period. So if you say ls space period, that will do the same thing as just ls all by itself, because the period gets expanded into the path to your current working directory. On the other hand, if you say ls space period period or dot dot, that actually gives you a list of the files one level up in your file system. And if you're in some bizarre directory somewhere, we say, if you're in that directory, I mean, if your current working directory is some directory somewhere in the file system and you want to refer to files in your home directory, you can use the tilde character to represent your home directory, whatever it may be. So ls space tilde will always give you a list of files in your home directory. Okay, so we'll take just a second to go play around with these commands once again in our terminal window, and let's cut on over there right now. Okay, here we are. So pwd prints my current working directory. Let's give it a try. pwd. Oh, my current working directory is the root directory. So let me say something directed only for users of Windows machines. You're using git bash. Git bash is actually, or Git for Windows really gives you a whole mini Unix operating system, including a file system inside of your Windows operating system. So really, when you're using git bash, you really have two file systems. You have one for git bash, which is kind of a complete Unix file system, and you have your Windows file system. So if you're a Windows user, you're probably familiar with your C drive, which contains the main file system for your Windows machine. If you want to see the files on the C drive using a git bash window, you could do it with ls/c. Okay, there's the files at the top level of your file system on your Windows file system. One of the subdirectories over there is called users. I've got that highlighted here, and that's the subdirectory that contains subdirectories for each of the users on your machine. So let's see how we can use ls/c/U users. Capitalization and case matter on Unix, unlike on Windows. Okay. So there are the files within the /users directory. inside of the top level directory on your Windows machine, and there's my Windows home directory. So if I wanted to see the files in my Windows home directory, I could say /c/users/sulli, and there's a whole bunch of files, some crazy stuff in there on my Windows machine. Now, if I wanted to be working extensively inside of my Windows home directory, I don't want to have to type /c/users/sulli every time I want to refer to a file in that directory. So I can change my home directory, my current working directory in the shell, to be my home directory in Windows by doing cd for change directory /c/users/sulli. Okay, and now my current working directory is my home directory on Windows, /c/users/sulli, and you can see that the slash here has changed to a tilde. Okay, which reflects the fact that I'm now working in my home directory. Remember, tilde is a shorthand for my home directory, whatever it may be. Okay, so my shell also remembers what my home directory is and allows me to refer to it using this tilde character. Okay, so within my home directory, again, I have a whole bunch of subdirectories. Let's see. One of them is called purse, okay, after a famous American logician named Charles Saunders Peirce. Remember, I'm here in my home directory now. If I want to get a list of the files in the purse directory, I could say ls/c/users/sulli/purse, and that would work using an absolute path, but I can use a relative path instead. I'm already working in /c/users/sulli, so if I just do ls without a slash and say purse here, I get a list of the files in that subdirectory. Okay. Finally, let me cd into the purse subdirectory, and here I'll do that using a relative file name. And now you'll see that your shell tells you, or tells me, in this case, that what your current working directory is, and then gives you this $, which is a prompt for a command. So now if I do ls, I'm getting a directory listing of the files in the purse subdirectory, because ls always takes your current working directory as its default path within which to do a directory listing. If I do ls dot, what's going to happen? Yeah, dot just means current directory, and so I'll get exactly the same result. If I want to see the files one level up in my directory tree, ls dot dot will do that. Oh, okay, that's just the home directory. That's my home directory, okay, because I'm inside of my home directory, down in the purse directory. From within the purse directory, if I say ls dot dot, I'm asking for a list of the files one level up. What's one level up above my home directory? Well, that's the users directory on my machine. So how about this? ls dot dot slash dot dot. That gives me a list of files 2 levels up in the tree. Aha, okay. And that looks like, yep, that's the users directory. There's my home directory. There's the home directory for one of my kids. And if I do ls dot dot slash dot dot slash dot dot, that should be the root directory of my C drive. Yep, there's all those crazy things you see when you look at your C drive, program files x86, and lots of other kind of Windows stuff. What about one level above that? Dot dot slash dot dot slash dot dot slash dot dot. Well, now I'm back above the /c file. I'm looking once again at the root of the Unix file system on my machine. I think that's good for now. what you should do at this point is crank up a terminal window and start looking around in your file system. And if you get really confused, or if you just want to get an even better intuition for what's going on, crank up a Finder window if you're on OS X, or a Windows or File Explorer window if you're on Windows, and poke around in your file system using your terminal CD, PWD, and LS. And what you'll see is that you have exactly the same structure as appears graphically in these graphical user interfaces. Okay, so really, Finder is just a graphical user interface that behind the scenes is using exactly these commands to get the lists of files that it's presenting to you, using icons and letting you manipulate using your mouse and pointer and so on and so forth. On Windows, File Explorer is just a graphical user interface that behind the scenes is basically using these same sorts of commands to get listings of directories so it can list the files in a directory that you choose. Okay, so what you'll see is that you now have a tool that allows you to move much more fluidly through your file systems than using these graphical tools, and we're going to have to be able to use these command line tools going forward. Okay, so that's it for now. What I'm going to do in the next video is to present a set of useful Unix tools. I'll do it quite quickly. There are extensive tutorials on command line tools for Unix-like operating systems on YouTube and elsewhere, but I'll highlight a few quickly so that you'll be able then to move on to the next stage of this course, where we're going to install a bunch of software and really get up and running. Okay, so we'll talk to you soon.